This is section 3.2, angles formed by parallines and transversals. This is the objective, proving used terms about angles formed by parallines and a transversal. There's no vocabulary, but you're going to see some of the terms that were defined on previous sections. Moving on to the next slide. This is the first postulate that you're going to see is postulate 3.2.1, and this is called the corresponding angles postulate. Very useful postulate. You're going to continue to use this throughout the book. Basically says if two lines are cut by a transversal, then their pairs of corresponding angles are congruent. So look at here. If you look at this picture here, all the corresponding angles, if you go to the conclusion, they are congruent. This is basically what this postulate states. Moving on to the next. This is the next set of theorems. If you cannot read this part of the video, you can just open the book and find the page that has these theorems. Here's what it says for 3.2.2. It says alternating two angles theorem. If two parallines are cut by a transversal, then the pairs of alternate interior angles are congruent. So 1 and 3. 3.2.3 alternate exterior angles theorem. Same hypothesis. Then the two pairs of alternate interior angles are congruent. So these are the alternate interior angles. 5 and 7 congruent. 6 and 8 alternate interior angles congruent. Okay, you're going to notice that 3.2.1, 3.2.2, and 3.2.3, they're all give you a conclusion of congruent angles. The one that doesn't is 3.2.4. Same side interior angles theorem, same hypothesis, says then the two pairs of same side interior angles are supplementary. So this is the only pair that gives you supplementary. All the other ones give you congruent. So in this case, angle 1 and 4, same side interiors, add up to 180. 2 and 3, same side interior, add up to 180. Moving on to the next slide. It says find each angle measure. If you look at the picture, they give you 133 and angle 1. So you're looking for angle 1 here. You should recognize that you're talking about same side interior angles from the previous slides. You know that these two angles are supplementary. So all you need to do to find measurement of angle 1 is subtract 133 from 180, and that's how you get 47. Number 2. In this case, notice this is the picture that you're given. Recognize that these two angles, 2 and 119, are corresponding. If you're looking for angle 2, since they are corresponding, you know that they're equal, so that's why this is 119. Moving on to the next slide. It says find the measure of each angle measure. They want you to find the measurement of angle DEF. These two lines are parallel. I forgot to highlight that on the previous slide, but I mean, notice that you had parallel indicated by the notation that represents parallel lines. Moving on, so these two angles are alternate interior angles, and you know that alternate interior angles, when they're cut, when you have alternate interior angles, you know that they are congruent. So then we have this. At this point, all we're going to do is we're going to solve for x. You can get rid of the degree symbol and work with the 8x minus 35 equals 5x plus 4. This is just algebra. Take away 5x from both sides, you end up with this. Add 34 to both sides, and you get 36 on one side and 3x on the other side. Divide both sides by 3, and you get x equals 12. Are you done? No. What you need to do is find the measurement of DEF. So you need to go over here and plug in for x, plug in 12. You do this, you simplify, 62. So this is your answer. Number 4. Again, parallel lines cut by transversal, and these two angles are same side interior. If you notice the previous slides, they tell you that these angles are Supplementary. So once you have this equation, again, you can drop the degree symbol, but you combine the 6x and the 3x. That's how you get 9x. Take away 9, you get 171. Divide both sides by 9, you get 19. You don't stop here. I'm looking for the measurement of CBY. So you plug it in here. 3 times 19 plus 9. That's what I have here. Simplify, you get 66. So this is your answer. Going on to the next slide. This one's a little bit different. It says, state the theorem or postulate that is related to the measures of the angles in each pair, then finding each angle measure. So in this case, we're talking about angle 4 and 5. 4 and 5. What kind of angles are these? These are alternate interior angles, and it corresponds to the theorem, alternate interior angles theorem. From here, you know that these two angles, according to the theorem, they're equal. 37x minus 15 equals 44x minus 29. From here, I'm not going to show you the math, but if you pause it here, you should be able to go through the math and end up with x equals, you can pause it, x equals 2. But you don't stop here, you need to find the angle measures. So you plug it into either one, because again, you know that these two angles are congruent. And that's how you get 59 for both angles, 4 and 5. Number 6. Here you're looking at angle 3 and angle 4. These two angles, which postulator theorem are you going to use? You're going to use same side interior angles theorem. Now, so what are you going to do with angle 3 and 4? Since they're same side interior angles, you know that they are supplementary. So that's why we have 23x plus 13x equals 180. Again, pause it, and you should be able to tell me what the x is equal to, which is x equals 5. Then, we don't stop here. You have to go back and find the measure of the angles. So you plug it into 3 and 4, or you can plug it in just to one and give me the supplementary angle to the other. Either way gives you the right answer. And that's how we end up with 3 equal 115, and 4 is equal to 65. 115, 65. Next slide. I know you guys enjoy two-column proofs, so that's why this one is here. It says complete the two-column proof to show that same-side interior angles are supplementary. So technically, from now on, this can be seen as a theorem. Okay, so you're given that P is parallel to Q. Notice it's given in the picture, and that's it. And your label, these angles are labeled 1, 2, and 3. And you're trying to prove that measurement of angle 1 plus the measurement of angle 3 is equal to 180. Notice that it's pretty straightforward. These two are corresponding. So these are equal, and you know that 2 and 3, they're supplementary. And this one is equal to, angle 1 is equal to 2, so you know that these 2, 1, and 3 are also going to have to be supplementary. So we're going to have to show that here. So here we go, statements. The first statement is P parallel to Q. That one's no problem. The reason is given. Statement for number 2. Notice that they give you the reasons is linear pair theorem. So what linear pair angles do you see here? 2 and 3. So that's why we have, under the statements for number 2, the measurement of angle 2 plus the measurement of angle 3 equals 180. So now, from here, you know that angle 1 and angle 2 are congruent. Why? Because they're being cut by this transversal, and I mean these two power lines are being cut by this transversal, and you know that angle 1 and angle 2 are corresponding angles, and they are congruent. And then at this point, I'm going to go from equality to, from congruence, I just added, to equality. So that's why I have this. Now, notice that my goal was to have 1 and 3 equals 180. I have 2 and 3 equals 180. So guess what I'm going to do here? Instead of writing angle 2, I'm going to substitute, and then I'm going to end up with 1 plus 3, which is what I have here, equals 180. What's the definition? Excuse me. What is the reason for step number 5? And here's the reason. Hopefully, if you think about it, maybe if you pause the video, you can tell me what goes here. But this is what you should be giving me. Substitution. And you're using steps 2 and 4. This is the end of section 3.2 video.